Okay, the video has started, that's fine. Okay, so this is what I like to call the first day agreement. It's a file that I showed you where you find it. It's in Canvas. I printed out a few things from a few assignments for you, so I give you a boost on the assignments in my lab math, but this is for later. We're going to start with this. And today is September 1st. And the first thing that I would like to ask you is to discuss with me, and we'll analyze them. And moving forward, we should always remember these so we don't have any difficulties. They will appear every class, more than once, every class. So you may remember these three special products or not. That's okay. We're going to work on them right now. So first of all, please tell me if you can see this. Is it clear for everyone? Okay, perfect. So what is this?
I can barely see that. My fault. I had to unmute myself.
You cannot see this?
Barely.
Who's speaking?
Aaron?
So I'm assuming it's something wrong. Does anyone else have difficulties?
I see the whole class. Am I supposed to see the whole class?
No, you are supposed to see what I write. So make sure you click on my name. Or maybe you pinned the video or something.
Okay.
Unpin the video.
I hear you.
Okay, everyone can see now?
Yeah.
Does anyone have difficulties? Jonathan, I cannot see you. Hello? Okay, he's out for a swim, I guess. Okay. So first of all, how do we call the a plus b? What does this represent? That's our first question here. What does it represent? Anyone remembers? Unmute yourselves. I'm sorry?
Two variables?
Correct, but this is specifically a binomial. When we add or subtract two quantities, like that, like the ones we have here, a plus b, this is called a binomial. So does anyone remember a binomial squared? A binomial squared. How many terms will that represent? Anyone?
Like 4 maybe?
Say it again.
Like 4 maybe?
Okay, so we don't remember. That's okay. That's why I'm starting with this. Okay. So for now, let's FOIL it. So obviously, a plus b squared is the same with a squared plus is the same with a plus b times a plus b. Would you accept that?
Yeah.
Good. So how do we perform this? We are going to multiply a by a and we get a squared. We're going to distribute a to b and we get plus ab. We're going to distribute b to a and we get plus ab. And we're going to distribute b to b and we get b squared. Is this understood?
Yes.
Great job. Now, obviously, I'm going to combine like terms. And I have here twice ab. So a binomial squared is a squared plus 2ab and plus b squared. Moving forward, we will remember that a binomial squared is, what is this again? Can anyone tell us if this is a binomial, what will this be called?
A trinomial?
Excellent. So this is something that you should put by your bedside if you want, or in your notebook, or never forget that a binomial squared is a trinomial. So in our first day agreement, we will remember forward, moving forward, this. Why is this so important? It's because we don't want to foil moving forward. We want to refresh our memory on factoring and other things. And factoring is based on understanding this formula or special product. So let's look at an example. Let's say 2x plus 3y, everything squared. First of all, how many terms do we expect to get?
3.
Awesome! A trinomial, because this is a binomial squared. So it has to be a trinomial. Great job. So what does this represent? It tells me to square the first term. Okay, no problem. When I square this, I get 4x squared. It also tells me to square the last term. No problem. 9y squared. And it tells me that in the middle, I have to have twice this product. So 2 times 2 times 3 is 12 xy. This is a step forward from foiling. Will you get full credit if you foil? Yes, but you will fall behind and you will have difficulties in factoring. So trust me, for my years of experience, this is extremely important to remember. When I'm asked to square binomial, I square the first term, I square the last term, and in the middle, I have this product multiplied by 2. So this product is 6xy multiplied by 2 is 12xy. What will be the difference? Any questions? Please unmute yourselves and ask any question. What do you think this will equal to then? Which is the second one in line? Can anyone give us, I'm getting a sip of water. Can anyone give us an idea of what will the answer be?
A squared minus b squared plus 2ab.
So, very good point. This is for this. These two are always positive. So
a squared minus 2ab plus b squared.
excellent. So let's write it in. A squared minus 2ab plus b squared. That's it. That's the only difference. And now let's do this. Let's say 3x squared minus 4y squared. Same pattern. Square the first, square the last, but now this is minus, I have to write minus. I multiply these two and then multiply it by 2. When I multiply these two, I get 12x squared y, multiplied by 2, 24x squared y. And it's done. Highly recommended. Last one. Any questions for me? Any questions? Last one. This is called the difference of squares. Let's assume that we don't remember what it equals to. So let's take it on the side. A plus b times a minus b. And let's say for the last time, let's foil it. A times a times negative b times a, and minus b times b. Look what happens this time. There is no 2. They're gone. That's why this is called the difference of squares. So coming back to our list, if you'd like to keep it on this form, you don't have to. Difference of squares. It's applicable only when these two are the same and these two are the same. The only difference is the sign in between. They must be identical, just this one of them is plus and the other one is minus. It doesn't matter, the order is not important. I can have minus and plus or plus and minus. So let's look at an example. Can anyone give us an example? Would you like to give us an example? Any?
Two x squared plus 5y, and then 2x squared minus 5y.
Excellent, of course. They have to be identical, just the sign, one is plus, one is minus. All we have to do is square the first term. Square the first term. Okay, 4x to the fourth minus. Square the second term, no problem. And it's done. Any questions on these special products? This was a quick refresher. It's very important for factoring and it's very important for moving forward. So when we square binomial and someone will say a squared plus b squared, we will say, you forgot the first day of classes. It's not a squared plus b squared, but x squared plus twice ab plus b squared. Okay, if I go too fast, you have to stop me. If I move the pages too fast, you unmute yourselves and say stop, go back, whatever you need me to do, okay? Any questions, please? Okay, I printed out your first homework. This is actually 1.1. What the system gave me, because the problems will be different for everyone. So let's go through something that we would like to see. So let's see what we're interested in. Plotting I know you cannot see this, but I'm reading those to you and we'll discuss them. And I will write as big as possible. Are we okay with plotting points on the coordinate system?
Yes.
If you're not, please say no, and I will show. Okay, I don't hear anyone saying no.
Can you go over it?
Just any plotting?
Yeah.
Okay, so for example, in this situation, I'm asked to plot -8, -4. So on the coordinate system, I'm asked to plot this point. So this is x axis, y axis. When we plot -8, -8 for x, -4 for y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And where they cross, right here, this will be the point -8, -4. Is that okay?
Yeah.
Perfect.
Thank you.
My pleasure. Anything that you need. Find 7 ordered pairs to the equation. So I like to work on that. We're given an equation that is y equals x squared minus 5. So we are going to call this a function a little bit later in chapter 2. But let me tell you what this tells me. This equation tells me that y equals whatever squared minus 5. The problem is asking us to evaluate when x is -3. Then when x is -2, and so on and so forth. Until x equals 3. That's what I have. That's what the system gave me when I printed this out. So what am I trying to do is I have to be careful how I replace the variable, which is x, in this box. That's what this says. This says to me whatever squared minus 5. If whatever is -3, then I'll have -3 squared. If it's -2, I'll have -2 squared, etc., etc. So when x equals -3, I have y equals, I have to use parentheses around -3 and then -5. By the order of operations, I get -3 squared, which is +9, and -5, so I get 4. The ordered pair that I just created is always x first and y second. So in this example that I was given, y equals x squared minus 5, I was asked to evaluate y when x is -3. In my case, I have +4. I fill this out, and let's say I'm going to choose the last one. Let's say when x equals 3, then I have 3 squared minus 5. The reason why I don't put parentheses is because I don't have a negative number. Can I put parentheses? Of course, it's not going to be a mistake. 3 squared will be 9. Minus 5 is also 4. Y equals 4. So it happens that I get, as an ordered pair, 3, 4. When x is 3, y happens to be 4. And the same thing with problem 6. This is just a quick refresher from the other classes. So the same thing with all the others. I'm going to just pick, let's say, y equals 9. Problem 9, I meant to say. Okay. So I'm on page 4. So we are asked y equals the absolute value of x plus 3. This is the equation or the function. And we're asked again to evaluate when x is -3, when x is -2, when x is -1, when x is 0, when x is 1, when x is 2, when x is 3. And also we are asked to graph. So in this particular case, I would like to do something else. In other words, I would like to create a table in which I put the values that we are given: -3, -2, -1, 0, 1, 2, and 3. And I will evaluate at each and every x value, and then I will graph. Ready? Can anyone evaluate for us when x is -3? What do we get for this? Anyone?
6.
Yes, because we know that the absolute value of a number is a distance from 0. So the distance between 0 and -3 will be 3. The distance plus 3, I'm sorry, 6. You were correct. I just rushed to write it. And I have to erase it nicely because I'm going to post this for you. Okay. Yes? Say it again. Okay.
Hold it up already.
Sure. Is that okay? So I just let it dry for a moment. So when x is -2, can anyone give us the answer?
5,
Excellent. When x is -1.
4,
Perfect. When x is 0.
3,
Excellent. When x is 1, of course, 4 and 5 and 6, and then I can go back and write 6 there. And now we're ready to graph this equation. -3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. -2, 5. -1, 4. 0, 3. 1, 4. 2, 5. And 3, 6. And here's the graph. Like a V function. The absolute value is like a V function. And this is y equals the absolute value of x plus 3. Any questions? So all the other problems are pretty much the same. I wanted to talk a little bit about a viewing window of the graphing calculator. Ready? Okay, so when you press on window, it will tell you what is the x minimum at the edge, left edge on the horizontal axis, what is the x maximum on the horizontal axis, and how far are the marks, the ticks. They're in my example at 0.2. That's the scale. They are the ticks that you see between 0 and 1 will be the distance one from each other at 0.2. Y minimum. At the very bottom, y, the minimum value for y is -2. At the very top of the viewing window, the maximum is 2. And I have a distance of 1. From 1 to 2. 1. I'm going to go to zoom, and I'm going to select the standard viewing window, which is number 6. So I don't need that a graph. I just wanted to look at zoom and standard, which is 6. No graphs. The leftmost point is at -10 for x, and the rightmost point is at +10 for x. -10, +10. -10 for y, +10 for y. When you get a problem like this that says -30, 30, 10, it means the leftmost point for x is -30. The rightmost point for x is 30. And the ticks are at a distance of 10. This is the information for the y. From the lowest y value to the largest y value, and the distance between ticks at 10. So let's create this. I go to window. It says from -30 to +30 with a scale or tick of 10. One more time. It was -30, 30, 10. -30, 30, 10. Now for the y values, the problem is saying -10, giving us -10, 60, and 10. So for y minimum, -10 is okay, +60 with a scale of 10. I'm going to put something so we can graph. Let's say y equals 2x minus 5. So I graph that. So -30, +30, -10, +60, and here with a tick of 10, and here with a tick of 10. 10, 10, 10, 10, 10, 10, 10. Is this clear? Okay. So then we establish that so you don't have difficulties with it. And then also in this section you have a couple of 4 problems with the table. So I would like to look at one of them. So your first homework should be done by tonight, because we went over every type of problem. So let's look at problem 13. They're very similar. If you have any difficulties with any of this is just a review from the previous course. There's nothing new here. Shouldn't be, but I went through everything. So let's look at 13 and see what it says. I know it may not be clear, but I will post this for you if you want. So the table of values was generated by a graphic utility with a table feature. Okay, fine. Use the table to determine which equation shown on the right corresponds to y2 in the table. So they don't care about y1. Don't even look at y1. We're only interested in finding which of these 4 functions is indeed y2. Any suggestions on how to address this problem? Any ideas?
Is it practical that we write these ones out on the board, since it's still kind of hard to see?
Yes,
printed
excellent.
letters?
Excellent. I'm open to any suggestions. And also, Please teach me. I hope I learn from you as much as you learn from me. If, let's say, your physics professor shows something better, easier, different, he or she uses a different method than mine that you think it's better and more appropriate, I want to learn it. So I rely on you to make me a better professor, please. So we are given y2 equals -4 minus x. We are given y2 equals x minus 4. We are given y2 equals 5 minus 4x. And we are given y2 as x plus 5. And the table, let me also copy the table, very good idea. So -3, -2, -1, 0, 1, 2, and 3, of course. And y2 is -1 and -2, -3 corresponding -4, -5, -6, and -7. All we have to identify, so this was for me problem 13, but for you it may be a different problem. So we only need to identify which function or equation works. So then what would you say? What will be the idea? What do we need to do?
I mean, you could substitute values.
Exactly.
But it would take a long time.
Excellent. Was it Sam?
Yeah.
Thank you, Sammy. Absolutely. So I plug in -3. -3 with minus in front is +3. And +3, -4 plus 3 is indeed -1. If I plug in -2, the opposite of -2 will be 2, minus 4 plus 2 is -2. When I plug in -1, yes, I get -3. When I plug in 0, yes, I get -4. When I plug in 1, I get -5, -6. So obviously, I don't even need to check the rest. When I check -3 here, I get -7, which is not -1. When I check -3 here, I get +12 plus 5, which is 17. Obviously doesn't work. -3 plus 5 is +2, doesn't work. Nothing. So that was it. So your homework is done for you. Okay. Any questions?
Wait, what do you mean our homework is done for us?
You have to work on it in my lab math. I just showed you an example from each problem.
Gotcha.
As long as you enter immediately after class, you're going to be done in an hour or less. Okay, so now I would like us to go back to our course, if you can get back in Canvas, because we have a little quiz that I would like us to start. So please log into Canvas. I'm hoping you're still logged in. If you're not, if the system did not log you out, sometimes the system logs me out. Do you see that assignment? It's under to do, or let me know if you see it and where you see it. It should be in the right column. Don't forget to complete the student introduction. And then in the right column, under modules, you will see the sections 1.1 and 1.2. Click on that quiz, please.